All right. Good evening. Good evening. So, looking forward to connecting with people today, right? We made a shift from our usual Sundays at 6 o'clock, right? Had some good family time and things yesterday. And so, definitely excited to get into this topic on this day with you all, right? Just a little bit of a shift, a little bit different, but still digging in. So, today we're focusing on really talking about a shift, right? Maybe what's symbolic. No, I'm just kidding. Talking about the shift, the main shift that math teachers would make, asking better questions. And I want to be super clear when I say math teachers, we're not talking about only people that are attached to a campus, at a schoolhouse, parents, talking to you as well, definitely, right? Because you are a young person's first teacher. So you're a math teacher too. Let me be clear. All right, good evening. Good evening, y'all. Thank you for joining. Thank you for rolling with us again with this shift. Okay. So while we're here, we're thinking, just really before we get into tonight's discussion, yesterday was the Super Bowl. So we wanted to work to get some Super Bowl real world connections in. All right. So here's a quick one. A team just gained 18 yards, but on the next play, they lost 7 yards. So how many total yards did they gain? I'll say it again. You can drop your answers in the chat. So a team just gained 18 yards on their last play. On the next play, though, they lose 7 yards. So how many total yards did they gain? Okay. Some of y'all are like, ma'am, now we came on here to listen, right? We know there's going to be a math quiz. But haha, the whole point, again, one of the things, yes, that's a very standard question that young people might be asked, but we want to make sure we're shifting away from just also what is the answer, but explain your reasoning. Like, how did you get your answer? How did you know this was a strategy we could use? They're starting to explain relationships between the numbers. That's the goal, right? The whole point is for us to understand that math is literally everywhere. So just in the classroom, you know, if we only ask, if just like in the classroom, we only ask, okay, so what's the answer? We're missing that bigger picture. So tonight, again, we're talking about how to ask better questions that build real problem solving, critical thinking in math. Okay, see, someone in chat said yes. 18 minus 7 equals 11. Yes, they have a positive 11 yards for sure. Okay. So then again, you get into, well, how did you know? What strategy did you use? So really digging deeper than what's the bottom line? What's your answer? Because again, these days, the questions aren't that way. There's very few questions that are only calculation based. Very, very few. So we're digging deeper. So if you ever heard a student say, or maybe your student has said, well, I don't know, right? You ask them, okay, well, how did you get that? Right? Well, how did you get that? What was your strategy? And they might say, well, I don't really know how to start. I just memorized some steps. My teacher said to do this, right? Again, y'all, this live is for you. So the most common, and especially if you are connected to a young person or you're a math educator in the classroom, right? Yeah, these are the top three responses. Then when you ask students to explain their thinking, this is what they say. I just knew it. I don't know. I just knew it. I did it in my head, or I don't know. Those are the top three. That's it. That's normally where they live. They're like, this is. And so again, even this shift. So shifting our questions so they can shift how they're thinking and approaching the question as well, their answers to the question rather. Right? So let's think about this. We typically may say, what's the answer? What did you get? So we're going to talk a little bit why that's not the most effective math question, right? So the brain, we're going to talk about the brain. The brain stores facts actually differently than deep understanding. So memorization alone is not going to connect right to application, right? Someone knowing 4 times 6 is very different than someone knowing when a situation is calling for them to multiply, right? If there's 4 baskets of strawberries, each basket has 6 strawberries. oh, I do need to multiply. So I will use 4 times 6, but the using it is much deeper. It's a much deeper connection. It's more connected, right? Our brain has little connections, right? It's a very basic level. Really, no connection is necessary in our brain to recall facts. It's very basic, very low level. Okay, so we're talking about some other common but less effective questions. We're going to flush all of this out. We're going to flush it out. So sometimes we may ask, okay, well, what's 1/2 plus 1/2? What if instead we said, okay, well, what might be a real life situation where you might need to add these fractions or where you might need to add fractions, period? Y'all, do y'all see the shift? Do you see the difference in the question? I'm waiting for your answer, right? 1/2 plus 1/2 slash, we're letting them be creative and create inside of math class, but also just in terms of building students' knowledge and understanding. Creativity, synthesis is the official term, right? That is the highest level of demonstration of your knowledge. When you show what you know and you can create something, whether it's creating a situation, a scenario, creating your own problem, that's the highest level of demonstration. So, as much as they can create, yes, even in math class, yes, practicing math at home, they need to be creating. They do, right? That is a critical part. We talked about this before. Creativity is a critical part, actually, of problem solving. If you can't see or imagine beyond exactly this, it's going to be difficult for you. So, we're also going to sprinkle in some AI connections. So, how can AI help with this? AI can provide step by step solutions, but we need to ask students to explain the why. So, because sometimes people might say, okay, well, they're just going to use, even if they use it to solve, explain why this is the way to solve it. Write a story for this solution, right? So, there's still ways so you can leverage and use AI, but still be able to promote that critical thinking in students. So we don't have to be scared. I want to make sure we're clear about that we do not have to be scared of AI, even in math class. Okay, another example of a question that is common, it's typical, but it's not as effective. So what's the area of this rectangle if it has a length of 6 and a width of 4, slash the flipped question? So can you design a room layout where the area is 24 square feet? What different dimensions would work? What are some possible dimensions of the room, right? And then, okay, AI tech leverage. Yeah, let them actually generate some shapes. Let them actually do the blueprint, a digital blueprint, right? There's tools like Desmos to generate shapes, Polypad, one on the Amplify website, one of my favorite websites. Listen, let them actually build it and do it, because too often we skip that step, not just to create, but where young people get to actually touch the math, I say, and make it real, right? So let's flip it as much as possible and let's give them opportunity to build it out. Super important. Super important. All right, another common question, another way a question is posed often. So, what is the probability, right? What is the probability of rolling a 3 on a 6-sided die, on a 6-sided number cube, sometimes people say? So, let's talk about this. If we played 50 rounds of this game, how many times do you think we'd roll a 3 and why? Man, it made them think about it differently. It's not just the basic question, okay, here's my answer. You're taking your knowledge that you know and you have to apply it, right? AI connection. We know AI can calculate probability very quickly, but the students need to understand why probability is useful in everyday decision making. So we can even do examples in terms of the weather, depending on the age of your child and what's on, in your space for the day. Y'all might be talking about financial literacy. You can look at the stock market. Well, right now, this is a good investment right now. Right now, they're saying this is not. So the probability, of us getting a return on this investment, is it high? Is it low? Just depending, right, on the age, especially, there's a lot of things that we do and we're constantly processing and applying information as adults. Again, the whole goal is to make sure that we're asking certain kind of questions. We're helping young people see the math every day, make these connections so that they're thinking more deeply. Um, Too often, it's common that students just kind of see math as something that as soon as I walk out of the math classroom, I'm done with that for the day. But the reality is, they're going to need their math foundation throughout their life, their entire life. And it's not really something that turns off and on. Okay, so just helping them make more and more connections so they can apply it better. So these questions, right? We said we're going to be going through questions, critical thinking questions that everyone should ask. We talked about some of the ones that are not as impactful. One of the questions is, if we ask, can you solve this problem a different way? Again, that encourages that flexible thinking where they're able to apply the creativity, right? Another example. So, what's another situation where this math concept would apply? Where's another situation where we could use this in real life? So, just like we talked about probability, we talked about the weather, we talked about stocks. Okay, lots of situations. We're talking about the fractions again, like we love to talk about fractions with cooking and baking, but also just kind of depending on, okay, we have some people that we are, sharing part of a budget with. Different. There's so many situations, you all, just encouraging them to think about it creatively. Okay. Um, Another question, critical thinking question. So, what mistakes do you think someone might make on solving this problem? Listen, listen. This that mistakes part. I would tell students when I was in the classroom, I would say, "Listen, I'm trying to put you on game. I need you to know what to look out for, so you don't do it later. I need you to know what to be careful about. And we'll make a mistake now. That's fine. So you don't do it later. We're going to get it out the way." I said, once you're aware of the common mistakes, your antenna go up, right? Your antenna goes up. You're in a whole different space for how you're focusing and working through the question. You're super careful, super analytical. Like, oh, wait, this has a negative sign. I know sometimes people will make a mistake. So let me think through. Okay. So once they see these kinds of questions, again, and they're trained and they understand, right? We've been practicing at class, in the class, at home, for what type of mistakes are common, what type of mistakes people may make on this kind of question. You are there less likely because we talked about it, we flushed out the details, right? So that's super, super important. I can't say enough about that, about the error analysis. I think it's the most underrated skill in the game. People don't use it enough, right? They don't go through different types of error analysis, but that's big. And plus, they reflection is critical, right? You're just doing stuff. No, let's call timeout. Timeout. Let's think about what happened. Did it go how it needed to go when we worked this question out? What were your challenges? Okay, if it did go well, what was different this time than the last time? Because you had challenges last time. So what went differently this time? So all of this reflection, all these layers of reflection are super impactful, super powerful. Okay. The real world connections, I can't stress enough. It just really, sometimes classroom life, right? People like to have jokes where they say, my kids keep asking me, my students keep asking me, when am I going to use this? When am I going to use this concept? I mean, start your lesson off that way. We've talked about this a couple weeks ago, right? Lead with the real world connections. Challenge them to create more, right? And then apply. Then they'll see how it applies in the real world. Because again, I can't say that you'll get that question, when am I going to use this? When you start off that way, you got in front of it. Okay. Another question. I'll give y'all a couple more. Another question. Can you create your own problem using this skill? What? You gave it back to them. And guess what? Bonus points, parents, bonus points, teachers. The strongest problems that were created, use that for some test questions, for some exit tickets. You just saved yourself. You got two things done. Let me be clear. You see and check in, you understand what they know, if they were able to write a strong question on the concept. And when it's time to give them the quiz, ta-da, there's your quiz questions already done. Hooray, right? You got a couple things done, y'all. So again, just being super creative. Again, the more we let them create, y'all, it's so many powerful things happening in the classroom. You're getting some of your time back, right? And you're starting to see and get your groups together, kind of thinking about, okay, these are the different groups, right? Where you might have your peer helpers and peer support, things like that. So, and this is an extra. It may not be the same people every time. A student that may be stronger in the geometry concepts may not be as strong in the number sense concepts. So just making sure you're paying attention as you're switching to the different reporting categories, different concepts, and different skills. Okay. All right, so another one, and this is the last one. Y'all, yes, I know we do have a lead magnet coming out. There's 10 critical questions. I'm giving you 5 here. Then yes, you're going to have to sign up to get the other 5. How about that? So the 5th and final question here for the live. How would you explain this concept to a younger student? Isn't that our own check as adults? What you've heard people say, tell me like I'm 5, explain it to me like I'm 5, right? So if we're talking about that and we have these different levels and layers, if you can explain it at a base level, simplify vocabulary, but the concept is still understood, then goal achieved, check and check. So if you're telling them to explain it to you like you're a younger student, slash, y'all know these Gen Alpha kids. And if y'all did not know, Gen Beta, that's the kids born this year. Gen Beta is on the map now. Okay. The Gen Alpha, they're very much used to vloggers and YouTube and things, right? So sometimes I'll say, hey, let's pretend you're making some content for YouTube. And we're talking about one-step equations. So what are some top tips? If you had to give 2 top tips, what would you say? What would you tell people that were coming to your content to check that out? It gives them a whole kind of focus because they've seen these kind of videos and things before, right? So just connecting and meeting them where they are for that. All right, you all. So basic math problem. We could do 18 minus 9 equals, but how could we reword this as a critical thinking question? Instead of just having students say an answer, what is 18 minus 9? How can we reword this so that it's a critical thinking question? All right, so we have some hints. Right, we could have them write out how they would explain how to solve it to a younger person, just kind of going backwards. What is a real world situation where we might be able to apply that concept? So lots of strategies, lots of options, you all. Here's another thing, a couple things. One, I want you to make sure that this week, as you're going forward, you got half of the 10, right? You have 5 possible critical thinking questions to work with. Only try one. That's another thing. Sometimes we're trying to do too much. Sometimes we have too many plates spinning and it becomes ineffective. Choose one of these questions per lesson. Okay? Integrating one thing at a time. So you can start tomorrow though. One of these questions per lesson. The students can generate their own, and making sure that maybe they have some of those prompts, those talking stems in their homework for their conversations at home for their math talks. Math at home parent tip. So instead of saying, right, did you get the right answer? Did you get it right? We can ask, how did you figure that out? Again, you all, these 10 questions, the full list is ready to go, a downloadable resource. If you want access to that list, please comment think in the comment section, okay? So you can go ahead and receive it. We'll get that sent out to you. And also, we're going to be breaking down not just these 10 critical thinking questions, but just several strategies to make students think more deeply in math. In our upcoming webinar, From Questions to Mastery, we're still promoting critical thinking in math, but making sure we're connecting how we can leverage tech, how we can leverage AI tech, more specifically, that support. Okay, so the link is live to register in our bio. All right. So we have so many things ahead, you all. So again, if you go ahead and comment think to make sure you have access to the downloadable resource for all 10 questions, you all, some questions that may come out as you're thinking and you're working on this with your students. How do I get students to explain their reasoning when they shut down, right? What if students get frustrated with critical thinking questions because they just want the answer? Slash, how can AI help students who struggle with math confidence? How do I get these questions to younger versus older students? And what's the balance between teaching procedures and pushing reasoning? So these are the kind of questions, you all, that will be answered during the webinar. So if you have any of these questions, if any of these questions are provoking thoughts in you and you want some more details, please do go ahead and register using our bio link, okay? So the final takeaway, the overall goal, y'all, is when we ask better questions, we build better thinkers. So we're going to make sure that we're making math more than just numbers, right? Because we understand at this point, we have a deep understanding that it's about curiosity, reasoning, and problem solving. So again, you can also send me a DM if you're watching part of this from any of the other platforms. If you didn't type think in the chat, in the comments, you can also send us a message with think, and I'll know what you need, and we'll get that to you, okay? Thank you all so much for tuning in, and I will see you on Sunday, right back to regular schedule very soon. All right, bye-bye. Thank y'all.